Okay, welcome to our 10th recorded class for Math 12. As you can see, the topic will be limitations of measuring instruments. Let's begin by reading the information, and then we'll look through a few examples. You should now be able to use at least 3 measuring devices to measure length: a ruler, a vernier caliper, and a micrometer. Each of these 3 instruments has its own limitations. Compare your answers to the list of potential limitations provided at the end of this lesson. Include on your resource sheet all these limitations, as well as the ones you come up with on your own. So the limitations of these instruments are going to be part of the last hand-in assignment for the unit. A ruler is mostly used for measuring length, width, and the depth of an object. Length times width times height, right? Volume, for the most part. You don't go beyond those 3 measurements. Rulers have many limitations. First, they're only precise to the nearest millimeter. And rulers have other limitations as well, certainly. They are usually cannot be used for objects that need to be measured very precisely. They are good for objects that are longer because you can use a tape measure, whereas a caliper or a micrometer, that isn't practical. Moving over to the vernier caliper, are used to measure the external and internal dimensions of an object, as well as, and there you go, there's one. Now the limitation of a ruler is external. You don't really use rulers to measure internal dimensions, as well as the depth. Measurements with a vernier caliper are more precise than measurements with a ruler, but vernier calipers still have some limitations. One example is the following. Some vernier calipers may be made of inexpensive material and therefore may not be as accurate as more expensive ones. And mostly they use digital vernier calipers today, together with your learning, and that's one limitation. And of course, it's a tenth. The micrometer takes a tenth of a measurement further, so it's not as accurate as a micrometer. There's another disadvantage. Micrometers are used to measure external dimensions and are more precise than vernier calipers, so they can't really be used for internal. However, micrometers still have some limitations. One would be they can only measure short lengths. You can't measure anything beyond 25 millimeters with a micrometer. And again, they're not really used to measure anything internally. So that's a few basic limitations. We don't need to go much beyond the basics with this. So let's have a look here, beginning on page 51, comparing the accuracy of precision measurement instruments. When precision measuring instruments are properly calibrated, in other words, they're measuring the correct distance, the instrument with the greater degree of precision should yield a more accurate measurement than the instrument with a smaller degree of precision. Consider the following example. So we're going to look at example 5 here. The length of an object is 5.7437 millimeters as determined by a very precise and accurate measuring device. This object is now measured 4 times with 4 different measuring tools. So here we have figure A, somewhere between 0 and 1 centimeters. Figure B at least breaks down the centimeters into millimeters, right? Because you can see that there's 10 markings here. So this is what? This is 1, 2, 3, 4, 5. This is 5.5 millimeters. So we're getting more precise already. And looking over here, getting even a little better, somewhere between 0 and 2 centimeters. And we know that it's somewhere between 1 and 2 millimeters. So let's take a look. 1.5 millimeters. And then we move over a little further and we get something like 1.52 millimeters. Okay? And now we have the micrometer. Okay, so let's find the measurement for each of these examples. Won't bother with the loose leaf. Let's just take our notes right in the book here. So figure A, it's between 0 and 1 centimeters. So the closest, we don't even need decimals. You have to take a measurement that you know. You can't pretend there's millimeters in between here when there aren't any. You've either got a 0 or a 1 for this measurement. That's all you have. So we could say that it's 1 centimeter plus or minus 0.5 centimeters, plus or minus half a centimeter. That's the most you can say because you don't have more information than that. Here we have 1, 2, 3, 4, 5. So it's somewhere between 5 and 6 millimeters. So we could say 5 millimeters, and it looks to be at about the halfway mark. 5 millimeters plus or minus 0.5 millimeters. Okay? Hope that's clear so far. They use the 6 in the answer key, but 5 serves the same purpose. Let's look at this here. We're talking about a measurement. Figure C. So our nearest whole number is 1. And remember how the caliper works. You take the measurement that's the closest here. Okay, so that's the other ones are a bit off. The very first one, just past. Okay, I don't know why I'm confused here, but I am. I don't get what they're doing with the answer key here. 0.57 centimeters, but I don't know what, I'll be honest, I don't know what they're doing with figure C. Rather than confusing you, I'll leave it out and go down to figure D. I appear to be missing something and I don't know what it is. But anyways, figure D, we're at 5 millimeters on the scale here. And looking over here, do we have a 0 or a 5? I'd say we have a 5. We're right there at the middle point. So we have 5.5, and then we're looking here, 21, 22, 23, 24. 5.5, 24. And you could be out by 100 of a millimeter because it is a micrometer, plus or minus 0.05. millimeters and millimeters. And again, I don't understand. Down here they have 5.74. Clearly on this scale it's a 5, and here we have a 24. I don't know where they are getting the 74 from. It just doesn't make any sense to me. And in fact, it doesn't. Where would you get a 74 from? There's a 24 here under the 25, or what? So there's something wacky about the way they did these examples, which is why I chose not to do figure C. I think it'll be clear enough for you anyhow when you look at some of the other exercises. Let's move over to some brain power on page 53. Number 1, extend the pattern. 9, 18, 27, 36. Should immediately become obvious that we're counting by nines. So the next two numbers are 45 and 54. Solve for x. 7/8, sorry, that should be a plus. 7/8 plus 4 is equal to x over 8. So x over 8 should be the same as 7/8 plus 4. Well, 7/8 plus 4 is obviously, put them together, 4 and 7/8 is equal to x over 8. So what I would do simply here is I would turn this guy into an improper fraction. 8 times 4 is 32, plus 7 is 39. 39/8 equals x over 8. So if this is equal to this, then therefore x has to be 39. If you're going to have 39 over 8 on both sides, then x has to be 39. And you can go back to the original question, 39 over 8, add these two together, turn it into an improper fraction, and you'd still have 39 over 8 on both sides. Claudia is 5 feet 5 inches tall. Calculate her approximate height in centimeters. 1 inch, they're telling us, is 2.54 centimeters. So 5 feet 5 inches. First of all, we got to get everything into inches. So these feet have to be in inches. So that is going to be 60 inches, because 12 times 5, 12 inches in a foot. That means we're dealing with 65 inches, and we're going to simply put that height into centimeters by doing 2.54 centimeters in an inch. So this is 65 inches. You're going to have more centimeters. 65 times 2.54, and I'm going to (165.1) centimeters. What is the perimeter of a triangle with sides measuring 3.6, 3.2, 3.6, add 3.2, add 4.1? And obviously all we have to do is add them together, because this is perimeter, all distance around. 3, 6, 10, 10.6, 10.8, 10.9 centimeters. Evaluate 3/7, take away 1/4. Common denominator here is 28. 7 times 4, 3 times 4. 12. 1/4, 28. 4 times 7, 1 times 7. 12 28 minus 7 28. 12 minus 7 is 5 28. Good. That's brain power. Let's just look at a few more exercises here concerning the linear caliper and the micrometer on pages 53 and 54. Consider the following scenarios. State which measuring device, ruler, tape measure, linear caliper, or micrometer is most suitable for each situation. Instead of hiring a carpenter to redo your kitchen, you have decided to install your own cupboards. Jag hoppas was already answered today's question. Which measuring device should you use? Rather obvious that you're going to use a tape measure, right? That's not using to get the lengths you need. You are trying to install your above ground pool in order to get the pump working. You need to measure the inside of one pipe to find another pipe that will fit. What should you use? Should be obvious that you're to use a linear caliper. You're measuring the inside. It's the only instrument that you can really use to accurately measure internal. You want the measurement of the inside of the pipe to know whether another one fits into it. Internal measurement, linear caliper. It's accurate, and the jaws can be used to measure on the inside. Simple. A mechanic for a stock car racing team must ensure the diameter of a crankshaft, part of an engine, to determine whether it is worn too much to use for the next race. Which measuring device should he use? So he's measuring the diameter of a crankshaft around the outside. Well, that's pretty precise business. To know if a crankshaft and a motor is worn out, you're talking about very small measurements, and the instrument that can measure the smallest measurements would be your micrometer. And you don't have to measure anything internally, it's all outside. So you're going to take the crankshaft out of the motor to measure it. Open your motor up, so your micrometer will work here, and it's your preferred instrument because that's very precision. You are measuring your room to determine whether your room is large enough for a queen size bed. Which measuring device should you use? I hope you're going to say tape measure. Consider a linear caliper number 2 and a micrometer that are calibrated properly. Explain which device would yield more precise measurements when both devices are used to measure the same objects. Obviously, your micrometer is more precise. It's 1/1000 of a centimeter, whereas a linear caliper is 1/100 of a centimeter. It's just the linear caliper has other benefits that the micrometer doesn't have, but when it comes to just straight out precision, it's the micrometer. Explain why these measurements are never completely accurate. There is no such thing as a certain measurement. It could be because your device isn't calibrated. It could be a faulty instrument. Maybe you didn't read it properly. There is always that possibility. It's just the way it is. And we'll leave it there. I'm not going to read this last part to you, limitations of measuring instruments. You can read it on your own. It gives you what some of the disadvantages are of a ruler, a linear caliper, and a micrometer. And as I said, this is not a long lesson. It's just under 20 minutes. And all you still have left to do is to read this last part And once again, there is no homework for this lesson. Your final hand-in assignment for the unit will be coming up after the next lesson. That's all for today.